Imagine your bones, the very framework of your body, slowly becoming as fragile as a piece of chalk. This is the reality for millions of people around the world living with osteoporosis. It's often called a silent epidemic because it can progress for years without any symptoms until a sudden fall causes a devastating fracture. This isn't just a minor inconvenience. A broken hip in an older adult can lead to a significant loss of independence and tragically carries a high mortality rate within the first year. The scale of the problem is immense, affecting an estimated 40% of women and 20% of men over the age of 50. As our global population continues to age, the burden of this disease is only set to increase, making the search for effective treatments more urgent than ever. To truly grasp the challenge, it helps to think of our bones as a bustling city, constantly being renovated. Throughout our lives, two types of cells are at work: osteoblasts, the builders that lay down new bone tissue, and osteoclasts, the demolition crew that clears away old bone. In our youth, the builders work faster, leading to strong, dense bones. However, as we get older, particularly after menopause in women, the demolition crew starts to outpace the builders. This imbalance leads to a gradual loss of bone mass and a weakening of the bone's internal structure. The once dense, honeycomb-like matrix inside our bones develops larger and larger holes, making them porous and incredibly susceptible to breaking from even a minor bump or fall. Current treatments for osteoporosis primarily focus on slowing down the demolition crew, the osteoclasts. These therapies can be effective at preventing further bone loss, but they come with limitations. They cannot rebuild the bone that has already been lost, meaning they can't truly reverse the condition. Furthermore, some of these treatments can have undesirable side effects or may lose their effectiveness over time, leaving patients and doctors with few long-term options. This has created a critical need for a new approach, one that doesn't just halt the damage, but actively encourages the builders to get back to work and reconstruct the bone from within, restoring its former strength and resilience. The social and economic cost of osteoporosis is staggering. The direct medical expenses from treating fractures, combined with the indirect costs of long-term care and lost productivity, place a heavy strain on healthcare systems and families alike. The personal cost is even greater, as fear of falling can lead to a less active, more isolated life, which in turn can accelerate physical and mental decline. This cycle of fear and fragility underscores the profound impact of the disease. Finding a way to break this cycle is not just a scientific goal. It's a social imperative that promises to improve the quality of life for millions of older adults, allowing them to remain active, independent, and engaged members of their communities for longer. In the complex world of cellular biology, a remarkable breakthrough has just emerged, offering a new ray of hope for treating osteoporosis. A team of dedicated scientists from the University of Leipzig in Germany and Shandong University in China have identified a specific molecular switch that plays a pivotal role in maintaining bone strength. This switch is a cell receptor known as GPR133. Think of it as a tiny antenna on the surface of bone cells. Its job is to receive signals that tell the bone when to grow stronger. This discovery, recently published in the prestigious journal Signal Transduction and Targeted Therapy, has opened up an entirely new avenue for developing treatments that could revolutionize how we approach bone health. The function of this GPR133 receptor is truly fascinating because it acts as a master regulator. When it is activated, it sends a powerful dual message throughout the bone's cellular community. Firstly, it stimulates the bone-building cells, the osteoblasts, telling them to ramp up their activity and create new, healthy bone tissue. Secondly, and just as importantly, it simultaneously puts the brakes on the bone-resorbing cells, the osteoclasts, slowing down the demolition process. This two-pronged action directly counters the imbalance that causes osteoporosis. It doesn't just stop the decay, it actively promotes regeneration, which is the holy grail of osteoporosis research and something current therapies simply cannot do. Interestingly, the researchers found that this receptor is naturally activated by mechanical strain. This explains on a molecular level why physical exercise, like walking or weight training, is so crucial for maintaining strong bones. The physical forces exerted on our skeleton during these activities send signals that are picked up by the GPR133 antennae, instructing the bones to fortify themselves. This discovery beautifully connects the dots between a healthy, active lifestyle and the underlying biological mechanisms that protect us from bone fragility. It confirms that our bodies are exquisitely designed to respond to the demands we place upon them, reinforcing our structure in response to physical stress. The significance of this finding was further cemented when the scientists studied mice that were genetically engineered to lack the GPR133 receptor. These mice developed severely weakened osteoporotic bones, proving that the receptor is absolutely essential for normal bone maintenance. Without this critical antenna, the bone cells never receive the proper instructions to build and maintain their structure, leading to a state of progressive decay. This crucial experiment confirmed that GPR133 isn't just one of many factors in bone health. It is a central and non-negotiable component. Targeting this specific receptor, therefore, holds immense promise for developing a highly effective and precise medical intervention. Discovering the GPR133 receptor was only the first step. The next, and perhaps even more exciting challenge, was to find a way to artificially turn this switch on without relying solely on physical exercise. To do this, the research team turned to sophisticated computer-assisted screening methods, sifting through thousands of chemical compounds to find one that could perfectly dock with the receptor and activate it. Their search led them to a newly identified small molecule named AP503. This chemical proved to be a potent stimulator of the GPR133 receptor, effectively mimicking the natural signals that tell bones to grow stronger. This was the key that could potentially unlock the receptor's therapeutic power. With AP503 in hand, the scientists moved on to animal studies to test its real-world effects. They administered the compound to mice, including a group that had already developed osteoporosis-like conditions. The results were nothing short of spectacular. In both healthy and osteoporotic mice, injections of AP503 led to a significant increase in bone production and overall bone strength. The treatment didn't just prevent further deterioration, it actively reversed the damage, rebuilding the degraded bone matrix. As Professor Ines Liebscher, one of the lead researchers, highlighted, AP503 significantly increased bone strength, demonstrating a clear and powerful ability to restore skeletal integrity in a living organism. One of the most compelling aspects of the study was what happened when the chemical treatment was combined with physical activity. The researchers found that when mice treated with AP503 were also allowed to exercise, the bone strengthening effects were synergistic, meaning the combined benefit was even greater than the sum of its parts. Exercise activated the GPR133 receptor naturally, while AP503 provided an additional chemical boost, creating a powerful one-two punch against bone weakness. This finding is particularly encouraging, as it suggests that a future therapy could be used alongside a healthy lifestyle to achieve maximum results, empowering patients to take an active role in their own recovery. What makes this potential therapy even more promising is that previous research has shown that AP503 also helps to strengthen skeletal muscle. This dual benefit is incredibly valuable for aging populations, where muscle weakness or sarcopenia often goes hand in hand with bone loss, creating a vicious cycle that dramatically increases the risk of falls and fractures. A single treatment that could tackle both sarcopenia and osteoporosis simultaneously would be a monumental advance in geriatric medicine. It could help older adults not only to have stronger bones, but also to maintain the muscle strength and stability needed to prevent the falls that cause fractures in the first place. The discovery of GPR133 and the remarkable efficacy of AP503 in animal models represent a paradigm shift in our approach to osteoporosis. For the first time, we have a clear target for a therapy that can actively rebuild bone. This is a profound departure from current treatments, which are largely limited to slowing the rate of decline. The potential to not just halt, but reverse osteoporosis could transform the lives of millions, particularly postmenopausal women who are at the highest risk due to the rapid decline in estrogen, a hormone that helps protect bone density. A treatment that restores bone strength could mean fewer fractures, greater mobility, and a higher quality of life in later years. Looking ahead, the path from this groundbreaking research to a widely available treatment will involve several crucial steps. The next phase will be rigorous safety and efficacy trials in humans to ensure that AP503 is both safe to use and as effective in people as it was in mice. Researchers will need to determine the optimal dosage, the best method of delivery, whether by injection or potentially a pill, and the long-term effects of the treatment. Dr. Julian Lehmann of the University of Leipzig rightly noted the great potential this receptor holds for medical applications in an aging population, and realizing that potential will require careful and thorough clinical investigation over the coming years. If successful, a therapy based on activating GPR133 could offer a new lease on life to those who feel their world shrinking due to the fear of a fall. Imagine being able to garden, play with grandchildren, or travel without the constant worry that a simple misstep could lead to a life-altering injury. This is the future that this research makes possible. By directly stimulating the body's own bone-building machinery, such a treatment promises to be more effective and potentially have fewer side effects than existing options. It works with the body's natural processes, rather than simply blocking them, representing a more holistic and restorative approach to medicine. In conclusion, this breakthrough is more than just another incremental advance. It is a fundamental change in our understanding of bone biology and a beacon of hope for a future where osteoporosis is a reversible condition, not a life sentence of fragility. The collaborative work of the scientists in Germany and China has laid the foundation for a new generation of therapies that could rebuild what has been lost, restoring strength, confidence, and independence to millions of people worldwide. While there is still work to be done, we are now standing on the cusp of a new era in the fight against this silent and devastating disease, an era focused not just on preservation, but on true regeneration.